In this example, we're given a graph, and we have some actual points on the graph that are listed, a few of them, but not all of them, because everywhere on that upside down parabola that's graphed on the XY axis, every point, every location on that upside down parabola has an ordered pair related to it. I just happen to list 5 of those ordered pairs, but there are infinitely many of them. You can choose any location and come up with the x coordinate and the y coordinate by reading the graph carefully. So I list a few for reference, and I drew the entire set of ordered pairs as that upside down parabola. Then we're asked to find the domain in the range. And then we are starting the problem with the abbreviation SLU / for solution. And let's get into it. Okay, so we are going to answer in 2 different types of notation. We'll answer in set notation and in interval notation. You should feel comfortable doing it either way. They ask first for the domain, so we're going to answer. The domain is the set of all the x coordinates in the set of ordered pairs. Well, I've listed 5 set of ordered pairs up there, but as I told you earlier, there are infinitely many ordered pairs. I just threw some up there. So if you just examine the x coordinates, as you move to the left on this graph, the x coordinates are getting closer and closer to negative infinity. See, we have 0 for the x coordinate in the middle, then we have -2 for the next x coordinate as we move left, then we have -3 for the next x coordinate, and those arrows down at the bottom indicate that it keeps opening as it moves downward. It opens side to side, so forever it's going to keep getting more negative values as it approaches, the x values approach negative infinity. Okay, what about on the right side of the ordered pair 0, 2? The x coordinates go from 0 as you move to the right to the number 2, move to the right to the number 3. So those x values are growing closer and closer to the value positive infinity. And there's no break in between. This thing keeps opening, indicated by the arrows, to the left and to the right as it opens downward. So that indicates that every real number will have a representation as an x value on this picture, this set of ordered pairs. So the domain, we'll have to write that in a set notation manner to describe all the real numbers for x. So curly set bracket, and then list x, and then this bar. Now let me tell you how to read that. That says the set of all x values, and then that bar, that means such that, and now we're going to list a condition on the x values. X equals a real number. Close your curly set bracket. So let me read that again. That says the set of all values x such that x is equal to a real number. In other words, that means all real numbers. In interval notation, you always start by listing the smallest value first, comma, and then the largest value. It's not an ordered pair. It's a set of all values, the smallest being the left value, the largest being the right value, and everything in between. So we have open bracket, negative infinity to positive infinity, open bracket. That means all values for x between negative infinity all the way through positive infinity. In other words, all real numbers. And you will notice there are open parentheses on the left and the right. That indicates whether or not you are including the values on the ends. Now, since positive and negative infinity are not real numbers, you cannot include them in this list. They're not even real numbers. We're only working with real numbers in this class. So we're going to put, well, at this point, so we're just going to put open bracket on the negative infinity, in other words, a round bracket, and open round bracket on the positive infinity. So that says everything from negative infinity to positive infinity is in the domain, not including the endpoints because they're not real numbers. Okay, let's answer the next part of the question, the range. In set notation, curly set bracket, all real values y such that, the bar means such that, okay, look at the picture. Y coordinates, those are on the vertical axis, up and down. Since the arrows indicate that the parabola is opening downward forever and ever, those values for the y-coordinates are getting closer and closer to negative infinity. But as far as the other direction, they only go as high as the y value 2. Do you see that ordered pair? The highest ordered pair on that graph is the ordered pair xy equals 0, 2. So 2, the y value 2, is the largest value. And 2 is actually included. There's actually a point living at that point, 0, 2. So 2 in the y-coordinate is actually a member of the set. So we're going to continue writing set notation, and we're going to indicate all the y values starting the smallest at negative infinity and then going all the way up and including positive 2. How would we write that in set notation? You would say y is less than or equal to the number positive 2 and close your curly set bracket. So that says the set of all real numbers y such that y is less than or equal to the number 2. Right? That's exactly what it says. So that's every number smaller or equal to 2. Now, how would you write that in interval notation? You have to list the smallest value first, comma, and then the largest value. Well, we already discussed the fact that the smallest y value, well, it's going to be close to negative infinity. So we put open parenthesis, negative infinity, and after the comma, we list the largest value of y on this picture. That would be the number positive 2. And then we do something very interesting. We put a boxy bracket on the end next to 2. We don't put a round bracket, which would indicate we're not actually including the number 2. We're just getting really close to it. But the boxy bracket indicates that we are actually touching the number 2 on this graph for the y-coordinate. And then we put a box around our answer, and we are finished.